Good afternoon, dear students.
Good afternoon, sir.
Good afternoon. So I think all of you are well and good. And today, actually, we are going to see another method apart from the Newton's second law and the D'Alembert's principle to find out the natural frequency of a single degree freedom system, which is undamped vibration. So for that, I am going to share my screen. Yeah. So for every system, so we have come to know that there is a natural frequency, provided the system is a single degree freedom system. For 2-degree freedom system, there will be two natural frequency, and like that, it will follow the trend. I think someone is. Okay. So in this method, so we will be considering the total energy of the system, and finally we are going to find out the natural frequency. So to find out the natural frequency, either we can find out the equation of motion, or directly by applying some analogy, so we can find out the natural frequency for any system. So till now, as I have told you, that we have opted two methods. One is Newton's second law of motion, which is applied to the free body diagram, which is in displaced condition. And then after seeing the external forces, or considering the external forces, so we found out the equation of motion. And the second one is the D'Alembert's principle. So in D'Alembert's principle, so what we have done, so we have introduced one force which is exactly equal but opposite in direction to the inertia force, and we consider the system to be in static equilibrium, and finally we will be getting the equation of motion and the natural frequency for the system. So here, this method, actually this is given by Rayleigh's, it is also called as Rayleigh's energy method. So in this method, so basically we will be considering the potential energy and the kinetic energy of the system. The other types of energies we will not consider due to the external sources, just like a friction. So this dissipative energy we will not be considering while
Sir,
defining.
Dikshita is waiting outside, sir.
Yes, who is waiting?
Dikshita, sir.
Actually, it should be auto admitted. Okay. So here in this method, so we will be considering basically two energies. So one is the kinetic energy, and second one is the potential energy. So why to consider the kinetic energy of the system? Because in free vibration, I have told you that there will be one initial motion which will be given by one external force. Okay, suppose we have just disturbed the system, but we will remove the disturbance and we will not use the disturbance after the initial disturbance, and we will let the system to oscillate, isn't it? So we will consider the total energy of the system is constant. So that means the kinetic energy plus the potential energy of the system will be constant. Then we'll be assuming that there will be no energy losses, so due to friction or any other energy dissipation will not be considered. Okay, means we will be considering one ideal system which is free from friction. Okay, or means there is no energy which will be forming due to friction. There may be little bit friction, okay, because every system, your wheels are actually, they can rotate on the floor because of the friction, but the total energy which will be there inside the system will be very much bigger than the energy which is forming due to friction. Okay, it is negligible. Okay, so that is why only we will be considering the kinetic energy and the potential energy. Okay, second one is if no work is done by external forces, thus we will consider that no work is done. Okay, because if we apply some external force and if some displacement it is happening, okay, so that will create some work, isn't it? So the total energy of the system will be conserved, isn't it? So if the we are not considering any work, external work which is happening due to the external forces, only due to the motion and only due to the position of the system, we are only considering that amount of only energy, then the total energy of the system will be constant, isn't it? So just like your closed system. Okay, so in closed system the total energy it is what? Conserved, isn't it? There is no mass interaction, but energy can interact. But sorry, that is isolated system. For isolated system, the total energy it is conserved, isn't it? So just like that, we will use this concept and we are going to find out the equation of motion. Okay, so you can see one below this writing. Okay, so you can see this derivation actually for a simple spring mass system. Okay, so for a simple spring mass system, so I can show you this derivation by taking so mathematically actually, so we will be writing T plus U. You can write other terminology also, KE kinetic energy plus potential energy, KE plus PE potential energy equals to constant. Okay, that means what? Total E is constant. So if you just differentiate total energy with respect to time, so that will be equals to 0. Means this energy is invariant with time. Okay, so means suppose 20 kilojoule of energy, if it is there at 12 o'clock, then at 4 o'clock also the energy 20 kilojoule for the system. It is invariant with time. Okay, so if you just differentiate any constant terminology, so you will get the value as 0. Okay, so we will use this mathematical concept and finally we are going to find out the equation of motion. Okay, so for a simple spring mass system, so one spring will be there, one mass will be there, so its translation in motion will happen only in this direction. Okay, longitudinal direction. This is a translational vibration. So total energy, I will be writing it as kinetic energy plus potential energy, which is constant. So what is total energy? Half mx dot square, because x is the displacement. So the velocity which will be acquiring by this body when it is displaced by an amount of x, so that acquired velocity will be x dot. So kinetic energy will be how much? Half mx dot square, isn't it? Half mv square, it is the kinetic energy. Then what is the potential energy of the spring? So potential energy of the spring or potential energy of this body will be half kx square, isn't it? Because all of you know the potential energy of the spring or this system, because we are concerning on this system, isn't it? So kinetic energy of this mass and potential energy of this spring, so it will be how much? Half kx square, isn't it? So this is the total energy. Other energies we are not considering. Okay, there may be air resistance. Okay, so we are not considering that extra amount of energy. Okay, only these energies directly related to the system. So this energy, if you just differentiate this total energy with respect to time, that is what it will be equals to 0, isn't it? So d by dt of E will be equals to 0 because E is constant. So if you derive any constant term, then you will get the value as 0. So d by dt half mx dot square plus half kx square will be equals to 0. So what will be the derivation? Derivative half 2 x dot, then again we need to differentiate x dot with respect to t, isn't it? Because it is not d by dx, it is d by dt. Understood? So already it is dx by dt. So if you just find out the differentiation, so half m 2 x dot, then again you need to differentiate x dot with respect to t, means what? X double dot. Okay, half m into 2x dot into x double dot. Understood? Then half k 2x into x dot, because it is not dx by dx, it is dx by dt. That is why you need to again differentiate x with respect to t. That is why x double dot term and x dot term will come. Understood? So simple mathematics. So it will be equals to 0. Then finally 2 will be cancelled out. Here also 2 will be cancelled out. So and x dot you can just eliminate x dot from each of the term, or you can write m x dot x double dot plus half will be cancelled out, kx x dot will be equals to 0. Okay, as because x dot cannot be equals to 0, that is why this term m x double dot plus kx will be equals to 0, because the system is having some initial values. Okay, the system acquires some velocity. Okay, not I am saying the initial velocity. The system acquires some velocity when it is displaced. Okay, that is why x dot cannot be equals to 0. Okay, so that means what? M x double dot plus kx will be equals to 0. So this is the same equation which we got actually when we have solved this spring mass system by applying Newton's second law of motion or D'Alembert's principle. Okay, so for this equation, so what is the natural frequency? So directly we can write that natural frequency of these systems, simple spring mass system in single degree freedom system which is undamped, so omega n will be equals to under root k by m radian per second. Okay, so this is the same formula, okay, or same expression as we have found earlier. Okay, then linear frequency will be f equals to 2 pi root over k by m hertz. So in both expression, so you need to actually finally find out the natural frequency for any derivation. Okay, because in numerical problem both the things may be asked, or sometimes linear frequency may also ask. Understood? I think this is very much easy. Okay, so I think no need to repeat it again. So okay, let's move to solve the problem, or you can see the analysis for your this one, transverse vibration. Okay, so you can see in the figure, so the simple spring mass simple pendulum it is there, so which is oscillating with an angle of theta. Okay, so by applying the same energy concept, so you need to find out the equation of motion for this simple pendulum, and finally you need to find out the natural frequency. Okay, so directly I am writing. So when you will have to write in your copy, then you should write that the one simple pendulum is shown in the figure. The bob is having mass m, and length of the simple pendulum is L, and it is deflected by an amount of theta. Then the kinetic energy which will be generated to the system due to this angle theta, or due to this angular displacement, will be equals to half I theta dot square. Okay, just like half mv square, so half I theta dot square, because this is angular displacement or angular deflection. Okay, so in mechanics, all of you have studied that kinetic energy of the bob will be half I theta dot square. So theta dot is the angular velocity, okay, and I is the moment of inertia of this mass with respect to this point, or with respect to the axis which is passing through this point O, okay, which is perpendicular to the screen, you can say. Okay, so half I theta dot square. So I have told you earlier that mass moment of inertia of this bob with respect to this point O, that point O it is not written, so better you should mark this point as O. Okay, so kinetic energy will be half ml square theta dot square. Okay, understood? So the bob acquires a position B after giving angular deflection. Okay, so you have given angular deflection of delta. So here there is a silly mistake. Okay, so it has gained, okay, it is not gained, it has gained potential energy as it has gained some height. Okay, here also ED, so here also ED will be added. So it has gained potential energy as it has gained some height, because you can see this height A, okay, and this height B with respect to some datum, okay, or with respect to this line, these heights are not equal. Okay, and somewhat it is lifted. This point B, it is in some upper side, depth of upper layer depth of A. Okay, means it will be lifted when it will get deflected a little bit. Okay, so you can measure that height, okay, by which it has lifted or it is lifted. So to measure that height, why we are measuring that height? Because we need to find out the potential energy, isn't it? To potential energy is what? It is the energy which is associated by the, because of this position of the system, because this system is placed in a conservative force field. Okay, that is why it will, because it has placed in a gravitational field, isn't it? So our gravitational field, it is there, so due to its height, so there will be one energy directly associated because of the height or the position. So that is the potential energy, isn't it? So we need to find out that amount of height. Okay, so we'll be finding out this H, okay, or this DA or AD, you can see in this figure. So one horizontal line, it is being drawn from this point to this point. Okay, so now we are going to find out this H or AD, this distance. So H is what? This total length of this bob OA minus OD. From this total length of the simple pendulum, you need to subtract OD. Okay, let us check. Okay, so OA minus OD. So what is OA? So it is the length of the pendulum. So OA is L. And what is OD? What is OD? So OD will be L cos theta. Why it will be L cos theta? Because this length is L. For this triangle, this length is L. If this is L sin theta, if this horizontal length is L sin theta, because this angle is theta, so opposite to this angle, the side will be L sin theta, and this base will be, okay, for this right angle triangle, so this base will be, OD will be L cos theta. Understood? So from OA we have subtracted OD, then we will get H. So O is small l because the length of the pendulum is L or string is L, and OD will be equals to what? For this right angle triangle, so this is theta, this hypotenuse is L, that is why this perpendicular will be L sin theta, so this base will be L cos theta. So L minus L cos theta will be the value for H. So after simplification, so we can make it common, L 1 minus cos theta. Okay, so we will do that while we will be calculating potential energy. Now the potential energy will be what? mgh, isn't it? So mg, instead of h, we will be putting L minus L cos theta. Understood? So we will make L common, mg L 1 minus cos theta. Okay, so we have found out the two main energies, as I have told in the Rayleigh's energy method, that only the kinetic energy and the potential energy of the system will be considered, because these two energies will be constant, okay, and these two energies will be having more effect than the other smaller energies, okay, due to friction or other dissipative energies. So we will not consider those small energies, so we will only consider these two type of energies. So finally we have got these two energies. So these two energies value, total summation of these two energy value will be constant, okay. So we will then differentiate that constant term, that will be equals to 0 with respect to t. So when you will add these two energies, total energy E will be equals to kinetic energy plus potential energy. So if you differentiate, what you will get? So dE by dt, this is capital E, okay. I think it is not this thing, I will share the PDF file also, don't worry. So this capital E will be equals to dE by dt, okay. So this will be equals to 0 by this principle, Rayleigh's energy principle. So d by dt, so half ml square theta dot square, understood? So this half ml square theta dot square plus what is the potential energy, mgl 1 minus cos theta will be equals to 0. Now you need to differentiate this one. Ml square will comes out because m is constant, l is constant. So theta dot is the variable. So half will be cancelled out. For this half, it is also half. Okay. So these will be cancelled out. Only l square will be there, ml square. And for theta dot square, it will be 2 theta dot into theta double dot, because it is not with respect to theta dot. It is with respect to t only. That is why you need to again differentiate this theta dot with respect to t. Then you will give, you will find theta double dot, okay. Then for this term mgl, so you can write for this one, it will be 0 minus cos theta will be equals to sin theta, because cos of derivation of the differentiation of cos is minus sin. So sines minus will be plus sin theta. Then for this theta again you need to differentiate, so theta dot will come, okay. So it will be equals to 0. So after simplification, so mm will be cancelled out from both the terms. So one ll will be cancelled out. So theta dot will be cancelled out. Understood? From the left hand side. So finally you will get theta double dot plus z by l, sin theta will be equals to 0. So as we know that sin theta is a what? Non-linear term. That is why we need to convert this into linear form. Okay, means theta is equals to 0. If theta tends to 0, then sin theta also tends to 0. Okay, or sin theta tends to theta. Sorry, if theta is very small, sin theta will be equals to theta, isn't it? Because if theta equals to 0, sin theta value is also 0. That is why if theta is very small, so sin theta, because theta is very small, it is 3 degree, 4 degree or 2 degree. Okay, so in that range only these oscillations will occur. So sin theta will be equals to theta. Okay, so finally you will get this equation. So from this equation, so what you can write, that the natural frequency of the system will be given by omega n will be equals to under root z by small z by l. So why this expression is not, because this is angular deflection, okay, or angular vibration, or you can say that this is transverse vibration. Okay, so in transverse vibration the formula will not be omega n will be equals to under root k by m. Instead the formula will be omega n will be equals to under root z by l. So where z is acceleration due to gravity and l is the length of the pendulum. Okay, so this way you need to solve the problems, okay, or you need to analyze any system by this energy method or energy principle. Understood? So other type of examples also you will get. Here you can see one example. Okay, I am giving this example as a homework for you. Okay, so here the question is directly not written. So from this figure directly you can actually imagine what will be the question. Actually you need to find out the natural frequency for this system. So there is a actually rotor. You can see this rotor, it is there, which is having some mass m, and the disk of this rotor is capital R, it is written. Okay, and it is having one, it is connected from a fixed end by a spring stiffness, by a spring of stiffness k, okay, or spring constant, it is having k, and it is having one linear movement also, which is given as x, okay, which is given as x unit per second, and the disk is also rotating on its axis, okay, with an angular velocity of omega. So what you need to do, you need to find out the natural frequency. So this system is frictionless. This say that this is frictionless. Actually, there will be little bit friction, but that friction will be negligible with respect to the motion of the system. Okay, that is why it is said as frictionless. Okay, so let's assume it is frictionless because this is only a theory subject. That is why. So this is frictionless. We are saying that this surface is frictionless, and the disk is rotating on its axis, as well as the disk is having one translational motion. Okay, so both the motions are there. The disk is rotating on its axis and it is having one translational velocity, okay, or translational motion. So finally you need to find out the natural frequency. Okay, so this is not that tough. Only you need to find out the kinetic energy and the potential energy. So there will be two types of potential energy, because one spring is also attached. Okay, you need to find out the potential energy for the whole system and the kinetic energy for this system. Understood? Okay, dear students, so if you have any doubt, so you can ask. Okay, so I will be clearing the doubts within 1 or 2 minutes. If you have any doubt, you can ask me. So no doubts. Okay, I am very much happy. Then you are satisfied. Okay. So one assignment actually I was thinking to give you before this puja vacation, but might be I will be giving it after this puja vacation. So you keep studying, okay, and just go through some reference book. Okay, you can download from the net also any reference book. So and you can follow that book. Okay, and if you have some doubt, then you can ask me. Okay, throughout the lecture also, after the lecture, or through WhatsApp also, or through phone call also. If you are not able to get it from your friend circle, then you can ask me. Okay, so first you should try with yourself, because when you are doing some group study, then some ideas, okay, so individually sometimes you cannot generate the ideas, but in group discussion, so some ideas may generate, okay, and that will help you in solving the problems also. Okay, and that thing you won't forget in life, that group discussion, okay, or that group study. It's online group study or WhatsApp group study. Okay, you can if you are having some major project group, there also you can discuss your doubts. All those things you can do. Okay, thank you dear students for listening. Now you can leave.
Sure.
Yeah, Manas.
So do you have any ebook regarding this subject?
Yes, I have 2-3 books, but okay, I will see the content. Okay, because earlier I had a few books with me, okay, hard copies books, but this time I have downloaded 2-3 books. But the thing is that I have not gone through. Okay, means those books are good books, but those contents are actually very, very big. No problem, I will share. Okay, I will share with you in the WhatsApp group or through Google Classroom. Don't worry. Okay, thank you, dear students.
Thank you, sir. Thank you, sir.
Sir.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.